Good afternoon. If you're interested in adding solar to your residence or your place of business, one question comes to mind. How quickly can I pay back the cost of the installation? Naturally, that's partly a function of the install cost, but it's also a function of the value of the production from the system. So today I'm going to take a quick look at two tools that you can use, one free, available to anyone and everyone, another that's a professional tool that we'll just mention and look at briefly, and we'll compare those to real-world production from an actual system that's been operating for this year. So we'll take a quick look at the first one being PV watts. PV watts can be programmed with whatever location you want to use. We'll enter a specific location and check our map to see if the map actually is correct, and then go to our system info where we'll enter in the size of the system and other parameters that we want to analyze. So in this case, we have a system size of 3.6 kilowatt hours, or 3.6 kilowatts, excuse me. Modules are set to premium. It's a fixed tilt system with a roof mount, and system losses are set at 20%. The tilt, which is the angle of tilt for the modules, is set at 50 degrees. The azimuth, which is based on the points of the compass, is set at 215. What that means is that we're pointing this array southwest. North would be 0 degrees, east would be 90 degrees, due south would be 180 degrees, and west would be 270 degrees. And we can take our system and with those parameters get estimates of annual production month by month. Before we settle for that, I'd like to show you quickly a feature that might be of use in your case. This is where we can actually draw our system right on the screen. And we do that by clicking the corners of the area where we plan to install the array. Once we've done that, we click Save, and it will estimate the size of the system that can be installed in that area. I find the results of this to be inconsistent. It doesn't give me the same size system in each case. So that's one more reason that if you're going to make the investment, to consider utilizing the services of a professional who will do this analysis quite likely for free. We certainly do these for free in each and every case. So I'm going to go ahead and go back, since this is an already installed system, and put in the numbers that are accurate for the install. We'll pull those results back up. PV Watts is a project of the U.S. Department of Energy. It's made available to the public for free. There's no subscription. You can enter in as many systems as you like, never be charged for it, and it's a pretty nice tool. So these are our results. We'll take a quick look at Helioscope, which is a professional tool. Helioscope offers the ability to actually enter in the specific modules that are being used, the actual inverter that's being used, and also allows me to put in buildings and trees, assign elevations to those as well as to the array itself, which will all impact the amount of shading that the array receives. All of that very critical to actual production and real-world results. But in any event, we see both of these do give us some numbers. Let's compare those numbers to some real-world results from the installed system. So I've gone ahead and I've logged into the inverter already. We see that it's currently operating. We are getting a current power production of around 1,300 watts. The system capacity is slightly above 3,000 watts. And what is happening at this point is we probably have some clouding, some clouds traveling across the sun, which can dramatically impact the yield at any given point in time. We can see that in real time. If we were actually to look outside, watch the clouds as they drift across the sky, we would see the numbers change based on how brightly the sun was shining at that exact point in time. So if we look here, we see we have actual monthly values of production. We're going to go ahead and take the highest producing month thus far in 2020, and we can see in July that we received 440.655 kilowatt hours from our array. So we're going to go ahead and round that off to 441 and compare that to the analysis from PV watts. So 441, significantly more than 407 predicted by PV watts. Helioscope actually predicted production in July of 427.7. Go back to the real world, and we'll look at the month of May, which looks like May was actually a little lower than April, which we would not normally expect. Probably a function of some cloudy days. Real world results in May of 379.2 kilowatt hours. To call it 379, compare that to PV watts, which predicted 382, and Helioscope, which predicted in May 418.6 kilowatt hours. Clearly there was some shading involved in May, impacting real world results from the system. So these are tools that show us some pretty good numbers with regard to estimated production. We can take those numbers, assign a value of production, and use that value of production to analyze a payback period associated with our production. Now, these results do not include renewable energy certificates, which will be a topic in a future video. Folks who live in Pennsylvania will receive roughly $20 per megawatt hour in renewable energy certificates, significantly less than is received in other states, but it's still money that you don't want to leave on the table, and money which can add to the value of your DC AC system, your inverter and your array. So we're always interested in doing site evaluations. I do those for free within our service area of 2-hour radius of West Henry, Pennsylvania, and we'll show you some pretty good analysis of what to expect in terms of production from your system and how long it will take to pay back. So I really appreciate your time looking at this, and you can reach us at 814-212-3836 or by email mike@greenprepper.com. Again, the phone number is 814-212-3836. And thank you for your time.